Good afternoon. $15. $16. Hi, Kiefer. Bad weather today. It's gonna be like this for the whole week, I think. Friday's gonna be cold.
It'll be nice to have
freezing right now.
Finally.
Okay, 19. We should have 25. One student dropped out. We're opening the floodgate now. Who's next? So we talked about the first diagram, the use case diagram. Okay. And I don't know if you have tried to apply what we talked about to your project, because that's something due next Monday, in addition to the class diagram we're going to talk about today. Yeah. Do you remember that? So, so what you need is you need think about what this program does, which pretty much we know, right? We know what it does. Let me see if I can share my screen with you. Kind of give you an idea what it does. Okay, so we're gonna develop an application. So whatever we want this program to do will be in the rectangle, right? And then that sets the business boundary. And then whatever we don't want to do will be outside. Okay, so we know that we have to have a module to do user profiles. Okay, user profile. We also have to have a module to deal with trails, right? Or trails management. Or you can just say trail management or trails. And then we need another module, say just the history. Okay, so there's a module dealing with the history, there's a module dealing with the user profiles, and a module dealing with trails management, right? And then, so roughly we know there are 3 modules, correct? Right, because we have 3 components. So when people go on to this application, use the application, they will, they will somehow engage with the 3 aspects of the application. So the user profile is then you have to decide who's going to use the user profile, right? Then you have actors. So this is just like a use. There's like a regular users. This is the users, right? That's the actor, and the user will connect to the user profile. So they can create a user account. They can update the user account, right? They can log in. That's all there, correct? Okay. And then you may also have some admins. Okay, say you're the organization, you manage this app. So you also have to allow people to administer. So we call them admin or admins, right? So admin is another type of actor, by the way. Actor is always using um, the stick figures to do it. So here's another one. Okay, that's admin. Oh, you cannot see my screen. You can, right? You can see my screen. Okay, so who can use the user profile? User obviously can see the user profile, right? Yeah, and the user admin is a type of user, right? Is a special type of user, right? So you may want to have something called generalization. So that means you may want a user to be a superclass, and the admin is a special type of user, so it's a subclass if you want to, right? Good. All right. But also, admin should be also be able to use the user as well, right? Because that's a subclass. So you also admin inherit all the capabilities of using the user profile. So the admin can create their own account, can log in, and then can do whatever the user can do, right? But on top of that, admin be able to manage the user profile. Okay, so admin should be allowed to manage user profile. Okay, manage user profile. Also, they're allowed to manage the trails, right? Admin manage the trails means they will create new trails, delete the ones that's no longer valid, or modify trails. And the users are not allowed to go in to manage trails, correct? Okay. Now, once you log in, then you will have something, you remember dotted line. I just call users instead of user profile, okay? So it's easier. So you remember the dotted line. Okay, that means that's called include. Um, or expand, actually expand, dash line, expand. So to allow the user to have the option to access the trails. So just call it trails. Okay, so this is just trails. So this is a manage. Okay, so once the user log into the user module, then you will give the user the option. Do you want to access trails? Right, you have the option because the user does not necessarily want to go look up the trails. They may just want to update the account or may just want to log in, see what's going on, read the news, read some kind of history. Has nothing to do with the trails, right? So this part becomes optional. Okay, that's called uh, extend, not expand. Why I say extend, extend. So extend means to have option, right? You could use the trail, or you don't have to use the trail once you log in, right? But if you do want to use the trail, then you can obviously. And then there's a history. History is included in, so you put the bad thing to write history over here. So I should have put the history over here maybe. So that is oval, that is a history, okay? So that is the part we're going to say include. So user must have a history, right? Even if you don't, it's a new user, but then history will be empty, but every user should have a history. Okay, so so that's basically what you 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 need. And now history though, history also must include some trail information, right? So that was extend include history. So it has to include some trail information because the history is made of trails, right? So so that is the rough outline. So if we go back to what we looked at last time, let me see if I can bring that page. It's called UML wait, umldiagrams.org dash. Okay. So I'm going to bring this page to you. And we're going to show you the use case diagrams. What is that? Add? I've never seen add before. Okay, here is an example of it, right? You see that? Okay, so that means group check-in is a module, and it has include a relationship, include individual check-in, right? These are associations. So these are actors. So we have a user, we have admin. Okay, admin is, so this is generalization because tour guide is a passenger. Okay, that's a super class. And when you have a closed empty arrow pointing to means this is super class, this is a solid line. Okay, so that's a super class. You have a passenger. So tour guide is it himself or herself is also a passenger. But on top of that, tour guide has some other responsibilities, right? So so basically that's what what it looks like. You know, you need a dash line. This is include means this is something you must have, and extend means that something is optional. Okay, so you have this idea and then you can try to organize your diagram. So it's simple, but it's okay, right? In the past, this could be very, when I make people do projects, it probably would be when it's too complicated, then people get overwhelmed. So this is so simple, so I would like you to think about it carefully and make sure, you know, you understand thoroughly. Okay, Jalio, your question?
Yes, I was gonna ask. I was looking into it onto the user case diagrams and to understand each terminology and each symbol.
Mhm.
But I see that there's some of them that looks way too similar to each other. How do, for example, the include and the extend? We just have to put it in, like, I guess, parentheses that this is include and this one is extend.
Yeah, so like in here,
Mm-hmm.
when you have this kind of relationship, which either is required or optional. Extend means is required. Include is required. Extend means optional,
Okay.
right? Because in order to group check-in, you have to have individual check-in. You have to do it
Mm-hmm.
one at a time. In still, right? You get each one passenger get
Okay.
each passenger get a pass. Each passenger get a seat, right? Get a number for the seat. So that's include, that means it's required. Okay. Now, extends means that is optional. Okay. Like when you, the user log in to the user, when the user log into the user module, they can just manage the user profile. Jelly, you may want to mute your microphone. It's making some strange noise. Okay, so so for example, the user can log into the user module just to update the picture, like a user profile picture, or change the password, or read the news or whatever, or just look at its history, not go into the trails and try to find a new trail to hike. Okay, so that part could be optional, so it could be extend only if you want to do it, right? Okay, then you also have to say who can do the login, right? So obviously the user can log in, can do the user module, but also the admins should be able to log in, right? The admin on one hand is just a regular user. On the other hand, it has other responsibility like managing user account, deleting user account, and also to create new trails or update existing trails. So that's the admin's responsibility, right? Okay, so so you have just like a few modules, and then you have two kinds of actors. That's what I think. Unless you want to make it more complicated, then you can have some other actors. But I don't want to make it too complicated. So this way you have time to actually think about this and
any other questions?
do it correctly.
Yeah, that was my question. Like, how many with like the use cases inside? Do we just need like
third-party
one for a user, one
libraries.
for a trail, one for history, like you showed, or
Mhm.
like I didn't know how much we need like the logging in and
No
all.
details. No details. No. You just
Okay.
okay. Let me reiterate. The purpose of the user case is to define the functionality, to define the capability of the application. You know what this application can do without telling how it's done. Okay, what are the features it has? Okay, you allow people to log in, to create a profile, to look up a profile. So that's all in the profile module, okay, user module. And then you also store trails. So people can look up trails, right? And search for trails. And then also they allow the admins to go in there to update the trails or add trails. Okay, and then there's a history part. The history belongs to each user if you think about it, right? Because each user's history should be different, supposedly, right? Because everybody, you hike your own hike, right? So that's part of the user profile, so to speak. But the history part also is a module in its own right because you can search history, you can display history, you can update history, you can go look up photos you took while you in the history, okay, stored in the information stored in the history. So that requires its own module. But you don't need to specify anything in specific. You don't have to say how many classes, what exactly, how many methods, and how things are done. You don't have to say that. So anyone who look at the user case, they know what the program does. What is included, what's not included. For example, people look at it will know that this thing does not include restaurants or include hotels because there's no module for that, or has no module for charging like credit cards because there's no module for charging credit cards, right? So people see the user case, the use case basically just saying how this program, how this application can be used, what are the features, without specifics at all. So this diagram should be roughly simple. I think it should be pretty simple with very few modules, and the relationship is pretty clear. It's pretty clear, right? And then each user must have a history module. You see that? You must have a history module because that's part of the user profile, right? You okay? So pretty general, this stuff, pretty general. There's no details really. But the only thing important is, the boundary. You have to say, this is what I'm gonna do. So if someone contract you to do this application, and you and the other party, you agree upon, what the features, what the functionality, then that's everything in the rectangle. So when you finish that, you should get paid. If you don't have this boundary, then the other party can keep on asking for more, right? Now you have something in writing to say, no, this is what we agreed upon. There's no credit card, there's no hotels, there's no ranking of services, um, things like that, right? Of the hotels. So that this is a document that clearly define what is included in the application, what is not included in the application. Ryan, you okay? Ryan?
Yeah, I was just wondering. You said I can use that to like define exactly what the client would say, but does that like actually have any legal weight, or is this just like a document I can reference at some point?
It's a well, whether it has legal weight or not, then that's a totally different question. So if you are an owner, say the owner wants you to develop this, you work for the owner, and you're freelancing for the owner, then this could be part of the legal document because it's something in writing. Now imagine you have an application, you don't have a diagram. Instead, you write out a document. You could do it, but the document will require a lot more writing, right? And then this is more visual, right? Everybody can tell without even people who have no idea about programming, they can tell what this program does. Okay, what is not included, what is included, right? So you just attach this to a real legal document that says, the scope of the work is presented in this attached use case diagram, and then that's it. Okay, right. So the alternative, of course, is to write it up in like a project proposal, and then you discuss in many paragraphs what this does. But people normally just present such a diagram, which is much more easier to understand without reading a lot of text. Okay, it's a standard, so to speak. That's how people do it. Okay, so at least you know there's such a thing. You know the meaning of those symbols. You know the boundary, the business boundaries that the limit, the scope of the work. Yeah, Jalio, what's up? You have to enable your microphone, Jalio.
My apologies. In the chart, I was saying that there's a part where it says Juan dot dot star, and it says like in multiplicity. Did you go over that already, or you're gonna go over it?
Say it again.
The multiplicity part. Can you explain it again, if possible?
Well, multiplicity explains or indicates the relationship between the two parties, right? That means when you don't have a number here, that means it's one. The default value is one. So one module of the individual check-in can manage or deal with one or many passengers at a time. Okay, so when we do check-in, I gave the example at the airport, right? The multiple workers working there, some helping you to take off your basically like ask you to take off your shoes, put your laptop outside in the tray, and then someone else is like pat down and make sure you don't have a weapon or something, right? And someone else will take care of that. The machine scan your body, make sure you don't carry anything, right? So they deal with multiple passengers at a time, right? So that's what it means. And Like here, group checking is every time you deal with one tour guide, 1, 1, because there's no numbers there. 1, 1. Okay, so that is that's group check-in. Okay, but now in your case, your application, right now the way we writing it or you guys write it, you each time when you log in, only one user can log in, right? Because we haven't really talked about multi-threading. Okay, multi-threading means multiple users can log in at the same time. Like a web application or mobile app, they will allow multiple people log in at the same time, right? Like, when you go Gmail, for example, many people can use Gmail at the same time. They can log in at the same time. But in our application at this point, we just allow one. So that's what, we've been doing, right? Just one thread, one at one time is one user using it, right? You understand?
Yes.
Okay. So now the same thing with manager. So if you want to update the trail, update the user, the administrator, is only one administrator at a time, right? You do not allow multiple administrators to go in to do it. Okay, good. Okay, yes, Ryan.
Sorry, just to follow up on that, the multiplicity is number of people accessing it at the same time, not number of things that person is accessing. So like only one admin, but not one admin dealing with multiple trails at a time.
Well, okay. If you think about it, right, you never have a case like a one person dealing with multiple trails at the same time. You never, because computer can only deal one thing at a time. So even when you try to access multiple trails, you're really just doing one at a time, right? For example, you cannot click multiple buttons at the same time, at the exact same time. That's what I mean, right? So you're really just doing one at a time, right?
I thought it had more to do with the relationships between the classes in terms of like how many potentially they can deal with. Like, so one user can look at all the different trails.
You can, but you
So,
can only do one at a time. You can only look.
but
You can have one action at the same time. One user, one action. The action could be display many trails at the same time. That's different.
so that's not what you would put with the numbers. You wouldn't put like say, in the case of a user, a user can only have one history, so that's one.
Yeah.
And each history just belongs to one user, so that's one on and one, so like one on both sides.
Mm-hmm.
One and one. But then in the case of like a history, they could have multiple trails. So that's how I picture. That's how I thought it was. A
Absolutely.
history is associated with multiple trails. So
Absolutely.
so isn't that what you would put for the numbers? So it would be like
Yes.
one dot 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 star.
Right.
And then on the other side too, it would be each trail can be associated with multiple histories.
Yes.
So
Yes.
it'd be one to star as well
Right.
there.
Right. Indeed. Indeed.
So you do that for like all the classes, right? You want to figure out
Well, we're
which.
not talking about the classes yet.
Okay, so is that in the other diagram maybe?
The other diagram, maybe, yes, but we're not talking about that yet.
I just remember because I was looking through the
Mhm.
textbook, and that's what they have in the
Mhm.
relationships between the classes.
Mhm. We're not
Okay,
talking about the classes yet. That's what we're
so
going to
you
talk about.
wouldn't do that here because
No.
that's not multiplicity. That's like more to do with threading, like you said.
Right. So right now, if
Um,
what you see here is Each tool guide will deal with one group check-in. Each group check-in module can deal with one tool guide at a time. But there's no specifics of which class is actually dealing with it. Okay, so
Okay.
if you have a web application, then just different. That means the same group check-in module can deal with multiple tool guides at the same time. They can all log in and then can do group check-in. Then that's called a multi-threading, multi-threads. And so we are not deal with that yet.
Okay, cool. Thanks. Yeah.
Okay. So all the details are going to be in the next diagram, the class diagram. Right now, there's no details. Okay, so you just allow people to like a diagram like this, use case diagram. You allow people who have no background in programming, they don't even know what a class is or Java, but they can understand what this program does. Okay, what they call a layman's language. They know that the group checking module can deal with one tour guide, but individual checking can do one or many passengers at a time. So one or many passengers can go up to the individual checking. Has nothing to do really with the classes, how you implement it. It's all just saying what's the capability. Okay, so multiple passengers can walk up to the desk at the same time and then get taken care of, right? So that's it's pretty straightforward, I think. The same thing with the security screening. Nothing to do with the programming again. It just a security screening module can each one of them can deal with one or many passengers, right? So usually they have 5 people standing at the security screening station, and then when you walk up there, you are dealing with multiple people at the same time, really. Right? Some will check your passport, some will, yell at you, some will tell you to put your stuff into the tray, some want you to take the battery out, some will tell you you have to take off your shoes, and somebody will pat you down, right? You know that, right? So that's what it says. So it has nothing to do with the programming, period. So don't even think about programming. Just think about the real life story. Okay, what happening, and that's what this is meant not for programmers as much as for the as like the owner or whoever the party stakeholders who want to know what the program does. There's no implication, how you should organize your classes or your objects. Nothing to do with that. Yes. Okay. Any other question regarding this? I mean, you should be able to do this, right? This is not that bad. This is not bad. Okay. Just make sure you use the symbol correctly, right? What do we call this thing? It's called a stereotypes. The angular 2 of those. There's a name. I forgot what the name of the symbol. There's a name for it. 2 angular bracket. That is called a stereotypes that allow you to specify the exact relationship. One is include, one is extend. Okay, and everybody knows what this means. So whoever knows UML will know what this means. Bueno. Okay, so if no questions, we're going to move on to the next diagram that is called a class diagram. Now that has everything to do with the programming. Okay, that is not meant for the third party to look at it, for the owner to look at it. Instead, it's meant for like a teammates in your development team. It's meant for them to look at it. So it will be so specific. it can be so specific. It doesn't have to be. Okay, I know this is, keep this in mind, all right? When you do your class diagram, it does not have to be exactly detailed, specific, but the major parts should be there. Okay, for example, when you specify methods, right? So it's not often necessary to specify all the getters, setters, because those are straightforward. But there are some major ones you should specify. And the data structures you may want to specify, right? So if you want to store trails, you want to store users, and you may want to specify the data structures to use. Okay, so those are major things. And things like NLMs, and if you do choose to use those one, right, you don't have to specify. So the critical things you do. Okay, so of course, if you specify everything with every bit of detail, then that the class diagram can be converted into Java code completely, into a functional Java code. Okay, completely. But that's rare. That would be very detailed. That may be even too detailed. It gets too overwhelming. So that's not required. That's not what I want. And to be upfront. Okay, what I want is the crucial part of the classes and the relationships between classes needs to be specified. So I don't require you to write your class diagram in such a way that it can be automatically, mechanically turned into Java code. I don't want that kind of detail. Okay, but I do want you to present the crucial components of it. So this way, another program, look at it, will know what you mean. Okay, otherwise your class diagram will be so detailed, so tedious, and then you can easily get lost by the extent, by its scope. Okay, so we don't want that. So rather we want to focus on the crucial parts of it. Good. All right. So now let's take a look at an example of a class diagram, and the class diagram is here. So so here is a class diagram. Huh. I thought I could. That's okay. I thought I could minimize a little bit, but okay, that's fine. So here's a class diagram. Okay. As I mentioned this before, each of the rectangle is a class or an interface, okay, or elom or whatever. Okay, elom is called enumerations. Enumerations. That's the full name. Okay, so all these are, as long as it's not a class, then you will, if it's interface, or then you will specify using like stereotype. Okay, that's in the double angled angular angular brackets. Okay, now regular class, you can use optionally. You can use entity, that's a concrete classes, or you can choose not to specify it. So now, one point I think often overlooked is when you do this kind of diagram, okay, is like writing an essay. Okay, you can choose what to be included or not to be included. Okay, so you can stress, certain things by including it. Sometimes you want de-emphasize other things, so you don't have to include it because you think that's is trivial, or it's not critical. So you just don't have to. So in other words, you do not attempt to make your class diagram complete. to the extent that you can convert it into Java code directly. Okay, it's meant as a communication tool to make your points. It does not meant to be complete. So don't feel bad. If your class diagram is not entirely complete, ready to be converted into Java code. Okay, but the whole idea is, again, you have to write a diagram in such a way that all the critical things you want to express is there. Okay, so for example, sometimes you don't have you may not even have methods. You notice, in fact, none of this have methods, but some has no. Okay, none of this methods. So we're going to see another diagram that has methods. Okay, so let me just dissect one rectangle. Okay. The rectangle is usually have 3 compartments. Okay, if you want to be complete, it should have 3 compartments. The first compartment is the name of this entity. So this is then a class name, author, and this book item is entity. You can call it the book, so or class. And then this is not the entity, the book. You notice this book is italic, the font. And that what it means. It means this is a abstract class. Okay, whenever you see italic, that means it's an abstract. Okay, no, it's not. Like a book, this is not, and this is not. That means this is the concrete class. Okay, now this is enumeration that you can tell easily. And then you can see this is the interface. Okay, if you want a stereotype, you put it on top of the name of the class or the name of the interface. Okay, so that is the first compartment, just the name. Like this one, it only has a name for this class called a catalog. It has no details, no mention of what the instance variables are used, what the variables used at all, and methods at all. Okay, so again, don't get overexcited when you see a diagram like this without those details. That's okay, because that means the person who's making this diagram do not think these names and the methods are critical, important here. You just try to make a point that you need a catalog, you need a class, without saying too much about it, which is okay, because it's meant to be a communication tools. It does not meant to be complete. Okay, of course, the more complete it is, the easier for people who want to develop the software with it, right? But it has many stages. So you can choose have it or not have it, have the details or not have the details. Okay, it's like in writing an essay, you choose what to be included, what not to be included. That's a big decision. Okay, no essay is meant to be complete, covering everything. Then the essay will never end. Okay, so don't feel bad, write the classes without all 3 compartments. Okay, so now I talked about each rectangle has 3 compartments usually, but it's not always the case. Now the first compartment is a name. In this case, because you see this italic, so you know that's an abstract class. And then that's what it means. So if you ever want to have a abstract class, then you want to make it italic. That's just the syntax you have to do. And here are all these variables. Okay, now or instance variables here. Okay, now when you have instance variables, we know in Java we would say public or private, right? Then return type, the name of the variable, right? If there's a value, we give a value. That's how we do it in Java, right? The first word is private usually. The second one is int. Third one is the name of the variable, like an age. And if you set the first default age, say 10, then you say equals 10, right? Okay, so that same information is expressed here. Okay, Now, the first thing is the name. Okay, so ISBN is a name. You see, ISBN is a name. And then title is a name of the variable. Summary is a name. Publisher is a name. Publication date is a name. Publication is a name. Okay, publication date is a name. Number of pages. You see, these are not even variable names because you see spaces in between, right? So they are not just an idea, right? Number of pages, language, this book is written, for example. So those are names. Now, see, some of them has the type information, some don't even have the type information. So ISBN, you see the type is always followed by colon, then followed by the data type. So ISBN is a string type, and also tells you square bracket. That tells you that is an array that can hold 0 to 1. That's multiplicity, 0 or 1 strings, right? Because ISBN numbers, let's say ISBN 10, ISBN 13. So there are two kinds of ISBN numbers in the real world. So that means each book can potentially just have one ISBN number, could be type 10, type 13, or could have both. So that means ISBN is really a string that can string array that can hold two numbers, up to two numbers. Could it be 1, could it be 0, could it be 2, right? So that's what it means. Okay, now you see there is a curly brace ID. Okay, that tells you the ID is unique. ID means that's a unique value. Okay, it's like ID we've been doing, like student ID and whatever ID, right? So that's what it means. So again, it's not meant to be complete. So always keep that in mind. Don't try to make it complete. You don't do things maybe because you think it's trivial. You don't put it in here. Okay, or you don't know what to do yet. So you could be doing your class diagram at the time. You don't really know what the data type, what the access modifier should be. Should it be public? Should it be private? Should it be package access? You haven't made up your mind yet. Then you don't put it anything. So like in this case, there's no place that indicates the access modifier. There's no place indicating this is a private or public or package access, right? Okay, so if you do want to do it, that's fine. And minors means the private, plus means the public, and you put them in front of the variable name. But nobody does it, so they didn't do it. And at some point, maybe we have an example that, yeah, you see here. Okay, so these are the and then this pound that it means is a package access, I think, package access, and the plus means I think it's public. Okay, I will double check, or you can look it up here. Or you just don't put. If you don't put it, that means right now either you think it's a trivial, or you haven't made up your mind. Again, it's not meant to be complete. It's like work in progress. It's just to express certain things you want to express. Okay, without trying to be complete. Okay, so so another example here is a title. That's a variable. Okay, and then you see that column, the title is a string type. Okay, these other guys is not even specified. Again, not try to be complete. You just say, I need that kind of information to be stored. Okay, so that's the super class, obviously, because it's abstract class. Okay, here is generalization. Remember that simple solid line with an open triangle, closed triangle, empty closed triangle. And the triangle is pointed as an arrowhead, pointing to the superclass, which is the abstract class. So this is a concrete class here. Okay, And now these are the variables. You see there's a barcode, that's a variable name. Colon, that means followed by data type, that is a string, and a 0 dot 1 means you can store up to 2 barcode for each book. Okay, and then the barcode is supposed to be ID, that means supposed to be unique. So whenever you scan the barcode, you can identify this book, okay, uniquely. All right, and there's another variable is called the tag. Okay, that's RFID. You know, that's another way of identifying things. That's another unique thing, and you can have a 1 to 0 to 1 or 0 to 2 RFIDs. Okay, you know the RFIDs, right? That's remote reading your information. Like we have RFID on our new passports. So technically, when we walk through the airport, the checkpoint, they can retrieve information. Okay, it's reference only, and if it's not specifying what the type is, probably you can figure this out. It's most likely it's a Boolean, right? Because it is. And so if it's italic, then that means that is this is not italic, and that means that is a static variable, but this is not. Okay, so that shows us the there's inheritance here. You see the inheritance here. Okay, now there's another class here called the catalog, and the catalog has no details. Okay, so if you have details, then you can specify, right? But in this case, there's no information. Okay, just because you don't want to put it down or you don't know what it is yet. But in your case, since you should know by now what data structures you're going to use to store trails and user profile or history, then you can specify them in here. Like, this type is a string array, or they can use a hash map or hash set or whatever, or tree set, whatever. So you can specify in that case. Okay, so in this case, we don't know. It's not specified. Okay, now the relationship between the catalog and the book item is association. Okay, that means they're related. Okay, because the book items are entered into catalog, so you can access the catalog by looking at that. And then and it also has a word here, so it records. Okay, just like the catalog records all the book items. Okay, that records book items. Okay, the relationship is association is very plain, general kind of relationship without giving specifics. Just they are associated, they're related. Okay, now look at the multiplicity. One catalog is either one can record many. Star means many items, book items. Okay, so when you do the catalog, you understand because one catalog can record many book items. So that tells you that you must have a data structure to hold a collection of book items. So here you must have a variable that has to be a tree set or array or array list or whatever data structure you can use. Right, because that's the only way to have one catalog to describe or record many book items. Okay, so that's reflected in this. Okay, so now we can just look at it here. Okay, and the catalog, you see that has a dashed line with a closed empty arrow triangle arrowhead here, right? And that means interface realization. Okay, now interfaces, they are abstract for the most part, right? That means the methods are not implemented for the most part. Although you can have implemented methods, I don't know if you remember, interface now can have actually implement method. Do you remember any of those? starting with Java 8, Java 9, you can have actual methods put into interfaces. Before Java 8, you can't. Every method has to be abstract. But starting Java 8, you can have some methods implemented in the interface. I don't know if you remember any of those. One of those is called a default method. You can put into an interface and finish up with the body. Okay, you can also have a static method put into an interface. So those features are added in Java 8. And in Java 9, you added private methods in interface that can be complete, meaning they are not abstract. You could also have a private static methods since Java 9 in interfaces, which are complete, as long as they are static, private static, I mean. Okay, so you can have 4 different kinds of complete methods in interface today. Okay, before, only abstract methods. You cannot implement any methods before Java 8, that's what I meant. And since Java 8, right, you can have default and static methods completed in interface. And then since Java 9, you can also have private methods and private static methods complete, meaning with the body in interface. Okay, so in general, though, we still think interface have unimplemented methods, right? If you have only one, though, we call them functional interface. I don't know if you remember that. But in any event, so the word is called interface realization. Realization means to make them concrete. You realize the potential, right? Because the interfaces are meant traditionally, they're not complete, they're not realized. All you have is the header of the methods without a body, right? So when you say interface realization, means you're going to have to complete those uncompleted or unimplemented methods by providing the body for the methods. Okay, so whenever you see that, that's what it means. So in Java's term, this is called implements. Okay, right? In Java, when you use a interface, you could implement interface, right? A superclass extends, remember? So this will be the book item extends book class, right? And here, then that means the catalog implements 2 interfaces, right? Java allows you to have as many interfaces as you like, but you can only have one superclass in Java, but you can have as many interfaces as you like. In this case, the catalog class implements both search interface and as well as manage interface. Okay, now you don't see any methods specified, okay, which is okay. But roughly, you know what that means, right? So that means the search interface will provide a method at least to search, right? The manage interface will provide maybe a bunch of methods. So someone can add a book item, delete a book item, or update book items in the catalog. Okay, so again, we don't have specifics. We don't have exactly what a method is, but roughly we tell people, we're going to break all the methods down into 2 sets. One's the search. One comes from the search interface. Another set from the manage interface. Okay, why we do that? We do that because we have librarians. They're going to be able to do search and manage. But regular patrons, they only do search, right? This is the example I gave in 148, maybe even 218, that you want to break down your interface into many. So this is where you can combine them. Like you have Malar Dark, they can quack, they can fly, they can swim, right? And then you have Rubber Ducky, they can quack, but they cannot swim, they cannot fly. right? So that's why you want to break all the behavior into multiple interfaces. So this way you can allow different combinations of behaviors, right? So that's exactly an application of that, right? Now imagine if you combine both into one interface, then it's harder to separate them. Then the patrons will have to implement that one interface to have all the methods implemented, right? Then the librarian also have to implement that one interface and then with all the methods implemented, right? For librarians, it's okay, but for patrons, it's overkill because you don't want them to be able to manage the catalog. Right? Make sense? Okay, so so that's why I've been saying that the interfaces are important. We're going to, after we finish this phase, when we talk about the design patterns, you're going to see how important interfaces are. Okay, what kind of benefits we can get by using interfaces. You can see you'll be you'll be amazed, how versatile interfaces are. Okay, so so these are the same. Okay, whenever you have a dashed line and then with an open arrow, and then this is called a usage dependency. Okay, so librarian will implement this and depended on this. Okay, so that's another kind of relationship. Okay, this relationship is called a dependency. Okay, that relationship is even weaker than the association. This kind of relationship. It just means they are related, but even weaker relationship. And then it's like a full-blown relationship. Is the use. You can use this. That's all. It's without really be very specific. So so you just like depend. So librarian depended on this. Dependent on this is one directional. It's not two directional. You just say librarian is the arrow pointing to whatever it uses, and then you have a word with a double angle bracket to specify what exactly the relationship. In this case, the librarian uses the manager interface, and the patron uses the interface. Okay, they use those methods, in other words, to do the work. They use the methods. Okay, now how they use that is not specified though. It's not really they implement those methods. It's not. So that's why it's so weak. The relationship is so weak. It only shows that the patrons use those methods, librarian use those methods. How exactly use it, not specified. In other words, do you want to implement those interfaces? No, not necessarily. All you're saying is they use those methods. They could be use the catalog. This contains a catalog in the patron and the librarian class. So if they have a catalog in there, then they can have those methods because you have a catalog object. The object has those methods. Then you can use them, but it's not specified. Right? It is kind of confusing, right? Because this is not the same as realization. It's not like the patron implement the search and librarian class implement the manage interface. It's not. It's not realization. All it says is, you see the dashed line with the arrow? It says, this is called dependency. All it says is dependent on it. How exactly it's going to be coded, how exactly to be dependent on it is not specified. Okay, so one way to use it is someone provide an object of a catalog to the patron and to the librarian. So it has a method to get a catalog. Once you get a catalog, then catalog contains the methods, right? Once you get an object of catalog, then you can use those methods because catalog contains those methods. Because the catalog, not they, it implements the search interface and the manage interface. So the catalog must have those methods, right? Concrete methods. But if you somehow the librarian get an object with a getter method, get an object of a catalog, then you can already use those methods. So it's different than implementing the interface. If you implement, that means you have to build your own methods, your own search, your own manage. But no, this is not that what it means. You don't. These guys, yeah, the catalog has to build its own search methods and manage methods, but this one doesn't. All it says is the librarian uses those methods to do things, to do their work. It's somewhat subtle, right? You understand there's a difference between the two, right? You use them without actually implementing them. So someone else has implemented, and then once you have that object of a catalog, then you have the methods, then you can use them. So it's not exactly you every time has to implement those methods. So of all those relationships, the weakest of all is dependency. It has no indication of how you're going to actually implement it. It's just saying they're going to use it. You're going to decide how you want to implement, how you want to make sure they can use it. That's all you have to say. Does it make sense? It's kind of subtle, but you do see. I hope you do see there's a difference. Yeah, but the other ones, interface realization, that's absolutely required that you're going to implement those two interfaces, and you need to implement those methods. Okay, so there's the difference. Okay, so when we talk about the relationships, right, we have 4 obvious ones. One is called dependency, weakest of all. Second one is association, stronger, and that tells those two things are related. Okay, and then you have something called aggregation. There you go. This is a weird one. You see the aggregation, it has a diamond in the end. The diamond is empty though. The empty diamond is pointing to the what's the word for it? The say host. Okay, so I tell you what that means, okay? And the aggregation, composition, okay, even association, they all describe kind of a relationship called has a relationship, but to different extent. So I'm going to explain to you. Okay. Okay. The of the 3, the weakest one is association, right? Which is stronger than dependency, but of the 3 of between association, aggregation, composition, association is the weakest of 3, and it has a relationship. That means a catalog has a collection of book items. Okay, that's association. Okay, good.
No, I think
Okay.
association isn't that aggregation?
Well, yes. Association is this is a Venn diagram like this. Association is the big circle. Inside the special set of association is called aggregation. And then inside aggregation, there's another subset, it's called is composition. So we're going to talk about this right now, okay? So let's go back to the diagram. So association, we could call all these to be association if you want to, but it's not very specific. You could say they're all associated in a very general way. That's fine. Nobody's going to say you're wrong, but you could be more specific. One thing you can be more specific is in this case, okay, that means a library has a collection of book items. You see this? A library has a collection of book items. So it has a relationship, but this relationship is it's tighter than just general association. So a lot of people like to say things like this: library owns book items. Owns is tighter than has, because has does not mean it's yours. Okay, I have a tool, but the tool can be borrowed. It can be, the life stamp can be someone else. It has nothing to do with me. Okay, and the aggregation means something tighter. Actually means owns. The library owns book items. Okay, so owns is tighter than has. So library owns book items. You know that's true, right? Library has a bunch of books, owns a bunch of books. Okay, not just the has books. Has book could mean that they borrowed books from other libraries, they put in their library. So that's like less tight. Okay, owns is more specific, that actually not only they have, but also they own them. Not only they have those books, but actually they own those books. So it's a tighter type of relationship. Okay, so that is aggregation. But you can also just say generally the has. That's it. You just has, and then that would be this diagram. Association means has. Period. I'm not going to discuss specifics. I just say has. Fine. So that's why association is such a big umbrella. Everybody is under association, including composition and aggregation. But aggregation is tighter. Okay, if you want be specific, only if you want to be specific. Okay, so to express that relationship, use an empty diamond pointing to the host, that's the library, the owner. Okay, now if you look at the multiplicity, you can also see that this one library can have many book items. Okay, so that is multiplicity there. Okay, similarly, a library owns many accounts. That's very specific. Those accounts are not from other libraries. This library owns those accounts. They're not borrowed. They're not transferred. They actually own those user accounts, right? Or patron accounts. Okay, so, and it also is the one to many. See, one library can have many accounts. So so that means you must have a data structure here in the library to hold user accounts, right? It has to be a data structure because it's not only one user, it's not one account, it's a collection of accounts. See, similarly, the library has another data structure to hold all the book items. Okay, so so some data structure has to be there to accommodate that relationship, right? Okay. Now then you also have this relationship we call composition. The composition is the tightest of all. Okay, another way to put it, people like to say composition means catalog is a part of the library. That's even tighter than owns. It is the library. It's just a part of the library. If you don't have a catalog, you don't have a library, in other words. Okay, because if you just owns it, you could unown it, right? You could say, I don't own it anymore. So there's a bunch of user accounts. I own them, I don't own them. It's not affecting me to be at the library. I'm still the library, but I don't have Tim's account. So what, right? I'm still a library. Correct, Tim? Right? But if I do have your account, then I own your account. Right? But if I don't have your account, I don't own your account, but I'm still a library. Comprende? Okay, that's different than the catalog. If you lose the catalog, the library has no meaning anymore. So the catalog is a part of the library. That's very different. You cannot lose it. If you lose it, there's no meaning to the library. The library cannot operate anymore. You cannot call the library if you don't have a catalog. So you can see this relationship is really, really tight. That's like tight as the wall. So that's why the diagram I drew before, right? Outside, very general association, fine. I don't want to deal with the specifics, fine. Or I can say, oh, this is aggregation. It's a part of. Owns. And then finally, it's composition that's the part of. So now, what's the implication of this? The implication is when you create those objects, when to create them, what's the lifeline, what is when they should be born, when they should be dead. Obviously, the catalog should be created when you create the library object. It's a part of it. So if you destroy the library object, the catalog should be dead too. Right? The life is associated with the library. Right? But book item not necessarily true. Right? You don't have to create the book item in the library. Right? Because if you don't have the book item, that's fine. Library still be fine. Also, if you burn down the library, the books should be still fine. They still be readable, right? Readable. Right? There's still books you can sell on eBay or sell on Amazon. See, the life is different. So these guiding you how to actually create, when to create objects of different things, in which class, because it determines the lifeline of each of them. Right? Those things are very subtle, but things you need to think about it. But we never think about this in 148 280, right? Because we just try to make it work. Okay, good. Does it make any sense? Right? Don't you feel like your understanding of programming get a little bit different now? Don't you think? Right? Because now you have more things to think about it. You become more sophisticated, don't you think? When you make a decision when to create which, at what time, and in what class, right? Should you create object inside another class, or should you just pass an object into a constructor of a class with the object already created? Right? Because you can create object inside another class in the constructor, or you can pass an object to another constructor with the object already created, because the lifeline is different. Okay, so these kind of questions will come up with interviews, and then so you will need to be able to address. Right, so this is all issues related to design. Okay, so if you want to be more sophisticated, you have to think about these kind of things. All right, good. And then what else we have? We have so finish this part, and here is also you see same as this. That's called usage dependency. That means account that uses account the state, and which is elum. Okay, there are only 3 states. Okay, one is sort of active, one is frozen, one is closed. So each account has one of the three states. Either it's active or it's frozen or it's closed. Okay, so that's elom. It uses that. Relationship is called a dependency. Very loose. However you want to do it, that's fine. It's not specified. And but in this case, it's used, you can see, as a variable. You see this? As an elom variable, account state. Fine. That's just one way to use it. Fine. But you make it so loose, if you want to do it differently, fine. But that's how it's used. Account state is a state. Okay. The number, account number, that's ID, you see? Okay, that's a history. In this case, is a history array. And I don't have a history class specified here. Yeah. See, it's not complete. There's a history class. It's not specified even at all, mentioned at all. It's just used. And look at the size of the array from 0 to many. But in your case, you don't use a array. You will use a linked list. Remember, for most part, we decided to use a linked list to maintain the order, right? So that's the history. So that's how you specify the data structure. Okay, and then opened, that's the date type. So column state, that means that's the date. Okay, so for your type of history for hiking, you also have a date in the history. Okay, so type is date. Now author, let's look at this one. And book item is abstract class. It has didn't mention the author, but you do see here there's an author class, right? Author class has two variables specified. One is the name of the author, which is string, which is kind of awkward. It should be a name type, because string for name is, it's not very good, because it's hard to distinguish the first name and last name. When you do search, it's hard to distinguish, right? You search by last name, nobody searches by first names, right? And biography is a string, that's fine, just the author's biography, that's fine. And everything else is not even mentioned. And here, relationship, that's what, the author, one author, see the multiplicity is one too many, right? And the book is one too many as well. So that's called the reading order or navigability. Navigability. That means the author wrote, okay, both can write. One author can write one or many books. Okay, now one book can be written by one or many authors. So that's both sides are one or many, one too many. One book can be written by multiple authors. One author can write multiple books. Yeah, right.
Why isn't that a more solid association? The author to the book. I mean, like, why isn't that aggregation and not? And it's because it's association right now, right?
Right now, it's just association is a very general relationship, right? Just means they are related, because books has authors, author write books, right? So it's not a owns. It's like an author owns the book. That's not true. You also know book don't own authors either. You don't also know that's author is not part of the book. That'd be crazy. You go to the library, you see a lot of authors are part of the book, and they drag the feed out and right. And also, book is not growing into the author's part of the author either, right? They can be separated. So of course, you don't want those tight relationship. That's a good example, right? So just association, that means they're related, but they don't have that kind of tight relationship. Like one cannot exist without the other one. One doesn't really own the other one. Okay, so so that is dependency here. This is account patron. Account has a patron that is has a patron has an account. Okay, it's one patron has one account. The patron has a name, has an address. Huh. So that break it down like that. It's kind of a little bit odd here. Because usually one patron and one account, right? And then you just combine them into one class. In other words, put the name address into here. Okay, but in order to show the relationship that that this is use the search methods, so it has a separate entity here. So that is also the has a, see, that's aggregation. So that means a patron has an account. Okay, aggregation means all of them has all of these has a, but different extent, different tightness. Okay, so that's even association is has a. So there you go. So one patron has one account because it doesn't say multiple here. If you have a star here, that means one patron can have multiple accounts, but one patron, one account. That's fine. But you didn't specify account here. You see this? There's no account. You could add account here. That means one patron has a account. So whenever you have association, aggregation, composition means has a. Okay, but then you can be more specific. Some have a relationship, so title is owns. Not only you have one, but you owns one. And then some is a part of it. Not only you have, you own, but it's part of you. That's even tighter. So what do you think? So now apply this to your project. And think about how many classes you need. And if you have ideas, what methods you have, what the interface you need, lay them all out. Make sure the critical part are marked down, like methods, search trails by search by name, search, or you can be general, just a search method because you need to search trails, right? And for the admins, they should have a interface allowed to manage trails. Okay, another one, manage the user profiles. So manage means they can delete, they can add, they can update, right? So you do not have to necessarily specify those methods yet. Like in here, you just say they can manage. And then the user can search trails. So they probably also should have separate interfaces to break them down. Right? And then you know that a user owns or use or the history is a part of the user profile. You can make it that way. So if you don't have a history, then you don't really have an account. You can make it that way, or you can make it just like a aggregation. That the history is a part of an account. That's fine. Okay, so then that governs how you're actually going to create the history. If history is a part of the owner, then the history has to be created when you create the owner, create the user profile. So that determines when you're going to create them, when to create a history object, in other words. If you want to create the history object when you create the user profile, then that means the history is a part of the user. If you want to just set a history whenever there is a history, to set a history to the owner, to the user, that means it has one. It owns one. It doesn't necessarily have one yet, or So that relationship is just like a setter. You don't really create a history at the same time as you create a user account. So that governs when you're going to create them. Then you have to make a decision how tight you want the history to be included with the user profile, right? And then don't forget though, you also must have individual. We just talked about the trails, profiles, right? Plural. That means you have data structures inside, correct? To hold many users, many trails, many history events, right? But don't forget, you need a specific classes too. You need a user class. Then the user data structure will make sense. Otherwise, it will make no sense, right? You also have a trail class. So the trail data structure class the collection will make sense. Yes, it's just like you must have a book item before you have a catalog. Catalog would be your trails data structure holding the book items. In your case, will be data structures holding trails holding trail or individual trails. So those all should be broken down to classes. Right? In other words, you don't want to simplify the whole thing here into catalog, into library. You have to have the specific things laid out as well, the account. So the user probably has to have an individual account. You can do the same thing. Okay, so the patron will have an account. So account is, it has a, you see, it's a separate item. So that means patron has an account, one-to-one relationship. Like the patron uses the search, kind of similar to this. Okay, then all those elums, you may have to create them as well. See the elums? Elevation gains, the types of trails, and all those. Don't forget those, right? So the diagram is not going to be very simple if you lay them all out. Okay, but it's a good thing now because you have a time now you can think about all the things you need and put them on paper before you actually write one end of code. Right, so this part will take a little bit of time to do it, and that's what we're going to do this weekend and finish by Monday. So Monday before class is due of the two diagrams. Doable, you think? It's interesting. It's interesting. Use those the UML makers to make them. Okay. And make sure the critical things are laid out. Now the getter says, oh, I didn't finish the third compartment. I've been talking about each rectangle has a three. You can have a three compartment, right? First one's a name. Second one's a variables. Third one with nobody has. There you go. Those are methods. Okay. This is the package access, and these are private, and then that's the only one has. Yeah, that's the only one has three compartments. Those are methods. Plus means public, and minors means private. I think so. That means private. That's what I remembered. You may have to look into it, but I think that's what it is. I often get confused. What else? This is the association. This is the dependency use. That is the aggregation, and there's no composition here. Yeah, that's the dependency. Generalization. So this is called implement. That's the realization. I think that should be enough. That should be enough. Okay, don't try to be complete. Don't put all the getters, setters. If you don't want to put the methods, don't put the methods. If you do want to put the methods because you have some good ideas already, you can put the methods in. That just put them in the third compartment. Okay, most importantly is try to figure out the relationship, how many classes you need, how many interfaces you need, elums, and also what the relationships between them. Okay, now in our case, in this project, it's not that complicated because we only have a few. But overall idea, there's a principle here you need to remember. That is, you do not want to have a design that has very complicated relationships. In other words, you want to avoid as many lines as possible. More lines you have, that means more relationships you have. Okay, now why you want complicated relationships? That's because if your program is built on complicated relationships, if you ever want to make a change to one part, it's going to have a lot of ripple effect. Can you see that? So you want to have more simpler relationship. So if you want to make a change, the effect is going to be much less. So if you have multiple solutions to the same problem, choose the one that has simpler relationships. In other words, you don't want things like patrons, in this case, patrons will search and manage catalog, right? Simple. But you don't want to draw another line between patrons and the book item directly. Okay, and you don't want a librarian to access book item directly, or in this case, it's not showing that it is. In this case, the librarian is not actually access the account either. So you don't want to have a lot of lines, a lot of relationships. So the librarian try to manage the author and try to search the author or something, by drawing a line like that. So you want to simplify it. Okay, avoid relationships. Sounds bad. As much as possible. Okay, so you live a more simpler life, which is true, which is really true, right? A lot of people trying to talk me into getting another dog. I lost my dog recently, and I've been resisting that. So that is something guiding principle. Okay, so when you finish your design with all the classes, all the lines drawn, then you say, can I do it differently? Can I simplify this? And that will allow you to make the program less rigid, more flexible down the road, so you can modify more easily. I think that's all I need to say. See if you have any questions.
we're uploading this to Git too, right?
Right. You should keep the commit history as we go. We're gonna add more stuff every week to the same project. So I want to see the whole commit history. I don't just want to see one commit in the end, upload everything in one shot. Okay, form a habit every time you make a change. Make a PDF file and upload there, okay, into the repository, and just call a folder called UML diagrams if you like, so I can see it more easily. Okay, now when you do UML diagrams, try to make them visible in one view, in one screen, something like this. So don't, in the past, people draw, say, this line very long, and then this enumeration goes into 2 pages away, right? Try to pack them nicely so you can see them all in one screen. Try. Okay, if it's too complicated, it can't be, it shouldn't be, then then break it down into multiple subsystems. Okay, so at least try to make them more compact. Okay, so make them look a little bit nicer. Don't try to, don't make it too ugly. Okay, and try to make it a PDF. So this way, easy to view. Good. Other questions? Yeah.
Just to get completely sure, Monday, do we have to have on GitHub the user diagram and the class diagram,
Yeah,
and
just
and those two, and then if you can, of course, improve into the project with the like the user class, like upgrade it a little bit,
say it again.
like as well to upgrade the project a little bit, like with the user stuff.
Yeah, that's the whole idea. So as you go, if you want to improve your code, improve your project, yes, of course. Okay. Yeah. So eventually you have a good, complete working project. Right. So every week we're gonna add new stuff to it. Next week we're gonna add something called design and the workflow. Okay, how we're going to actually design this application and implement it. We'll define a workflow. What we're going to do first, what we're going to do next. When we're going to actually implement those classes. That will be like next week. Okay, we'll talk about the design principles. One is called a waterfall. One is called a Scrum. So we're going to talk about that next class on Monday. Okay, we're going to break the whole project down into phases, into stages, and then you're going to finish stages at different times, and in the end, we'll combine them into a complete application. And then another week, we're going to do documentation. Okay, what you do for each, what you're going to explain to people how to use your application and how this whole project was put together. Okay, so like Java doc. Remember Java doc? We've been watching Java doc, reading Java doc for different classes in Java. So we're going to document all our classes as well. So people can look at your classes, they know how it's putting together, what the methods do, and what they return, what parameters they have, and building us into websites, like web pages. And then another week, we're going to do testing. So all the methods you wrote, the critical ones, you can write a separate methods to test them. Make sure those methods are correctly implemented. There are no bugs. No no logical errors in there. Of course, it shouldn't have syntax errors. We know how to find out those, but sometimes we have logical errors too. So we want to learn how to write code to test it. Then we can come back and refactor our methods to make the methods more readable. Once we know how to test them, then we can easily change any way you want, test it right away, see if the method still works. Okay, so every week we're gonna make some progress. And then we're gonna move on to design patterns. We're gonna move on to multi-threads. But so hopefully you're not gonna ask me for extension. So from now on, every week you should finish so we can move on, right? Okay, so promise me that. Okay, so any other questions? No? Okay, I see you next Monday. You enjoy your weekend. Okay, bye.